Hi, I'm Helena. I'm at Intel, where we make OpenVINO, an open source toolkit for AI inference. I will start this talk by giving a very quick overview of what OpenVINO is, what AI PCs are, and then we'll go into some practical applications. So if you have an AI model, for example, from PyTorch or TensorFlow, OpenVINO can optimize that model, and then it lets you run it on a variety of hardware. For example, CPU, GPU, or NPU. And it lets you do that without having to change a lot of your code. So you don't have to move the model to a device, remember which inference precision works best on which device, etc. OpenVINO handles that in the background. So we mentioned NPU. AI PCs are computers, laptops, or desktops with the latest generation of processors that include an NPU. And for Intel, that's the Intel Core Ultra processors. We are currently at the second generation, codenamed Lunar Lake, and the third generation, codenamed Panther Lake, is around the corner. And NPUs work fine with OpenVINO and are fully supported on Ubuntu with an open source driver. AI PCs also still have a CPU and GPU that you can use for AI inference, and our GPU driver is also open source. So it's really valuable that both drivers are easy to install with apt or snap. And here you can see that the performance keeps going up. So OpenVINO is not limited to any particular kind of model. It was started as a framework for computer vision inference specifically. But recently, generative AI has gotten a lot of popularity, and OpenVINO Gen AI is our answer for that. It's a framework that sits on top of OpenVINO, and it adds very easy pipelines to run inference on generative AI models. And that's, for example, chat models, image generation models, those kinds of models. Makes it really easy while still remaining a small footprint. So OpenVINO is really about running models in production, where you absolutely do not want a Python dependency hell, for example. It's also easy to install, and it runs everywhere where OpenVINO runs. So I said easy, but I would not blame you if you were a bit skeptical. So I wanted to show what does easy look like in this case. This is a Python and a C++ example, and as you can see, the code is also really similar, so you can easily switch between Python and C++, use for prototyping and production, for example, or even start learning C++ if you are a Python developer. So in the first line, we load the LLM pipeline, in this case Qwen3, and then in the second line, we add a prompt and the generation parameters. So pretty easy, I think. So OpenVINO and OpenVINO Gen AI are the runtimes. They're mostly used for local device deployment in a lightweight manner. We also have a model serving solution, and that's OpenVINO Model Server. It's again lightweight, I keep saying this word. The coolest thing I think personally about OVMS is that it exposes standard APIs. So if you already use some other model server, you can really easily switch to OpenVINO. It's written in C++, so it's fast. It's for computer vision and Gen AI models. So OpenVINO, OpenVINO Gen AI, OpenVINO Model Server, that's what we make internally. We also have integrations in other popular libraries, for example, Hugging Face. And if you already use those libraries, you can often get OpenVINO optimizations by changing only a few lines of code. So that's really powerful. However, there are often downsides. For example, you then certainly do have a whole bunch of Python dependencies, or you don't get the very latest OpenVINO optimizations. So in that sense, native OpenVINO is often best. And this is where the inference snaps that were announced yesterday are actually really interesting, because that leverages OVMS, which is native OpenVINO, best performance, so no downsides there. And it's just a snap install, so no downsides on the maintainability, installability, those parts. So kind of best of both worlds. So I wanted to do a live demo. Yeah, exactly. So we decided against that, and you get this pre-recorded demo instead. I am happy to show to anyone afterwards. So what you can see here is I'm running the DeepSeek R1 snap. I'm not sure if I can pause this. It's running on Intel NPU. which you can see because this is a very awesome resource monitor that shows here that the NPU usage was spiking when I ran the DeepSeek model. And I configured the Qwen model to run on Intel GPU. This is the integrated GPU in the Luna Lake NUC. And here I had a simple Gradio demo where I just upload some images. And you can see here in the resource monitor that the GPU usage is spiking while the inference is running. And you can also see that the model is pretty fast and not always extremely accurate. But yeah, that's the limitation of the model. So that concludes my demo. I'm now handing it over to Will, who will go to some more practical applications of using OpenVINO with snaps.
Awesome. All right, thank you very much. Hi, everyone. I'm Will, and I am going to be talking about building snaps of OpenVINO and OpenVINO-powered applications. So first things first, elephant in the room, why snaps? There are a number of reasons. The primary reason I would say is the complex dependency tree. And this is true not only of OpenVINO, but AI libraries in general. And as an example, with OpenVINO, if you want GPU acceleration and you want GPU and NPU acceleration, it means you need to have all the drivers for those things installed. You need to have the runtime libraries and dependencies present on a system, which from an end user perspective can sometimes be very finicky and error prone. And so the advantage of a snap is we have this containerized format where we can bundle all of those dependencies into the snap and sort of relieve the user of that responsibility. Second big reason is desktop usage. And so it turns out that a lot of the downstream plugins and applications that OpenVINO power are targeting the desktop. And that's an area where snaps really thrive. The ecosystem around desktop usage is very mature. There's a snap store where it's easy to discover things like plugins. And so that's another strong reason. And then the final reason are sort of features you get out of the box with snaps across all snaps. And that's support for multiple versions through tracks and channels, and also multi-distro support. And that can mean both multiple OS releases of Ubuntu itself, so you can run on the latest LTS release, you can run on the latest interim release, such as 25.10, all using the same snap, and you can even in some cases run across multiple distributions of Linux. And so just to make sure everyone's on the same page, I'm going to introduce some of the basic features of snaps. And the first one being the idea of containerization. This is something I've already mentioned. This is the idea that you are packaging not just the application, but all of the application's dependencies into a single package. And in general, a snap is designed with security in mind, and so it's designed so that it's not able to access anything on the host system, which includes libraries, but also can include things like device nodes and network interfaces. And so this is referred to as confinement, and if you want to reach out of that confinement, then you use something called an interface. And so snaps use interfaces to enable you to access things like a GPU device node or a network interface. And one of the really key important interfaces that I'll be talking about in this talk is the content interface. And the content interface provides basically a mechanism for breaking that first rule of containerization. So it allows you to have two independent snaps where one snap is consuming libraries from the other snap. And that's the most traditional use case is you have a content producer snap, which is colored orange in this slide, which has some .sos that are needed by a content consumer snap, which is captured by this blue block. And one content producer snap that now exists is OpenVINO Toolkit 2404. And this is published in the Snap Store. It includes the OpenVINO runtime, which includes an API front end so that it can handle converting between various different model formats, as well as device plugins in case you want to run on a GPU and NPU. It also has OpenVINO Gen AI, which is the package that Helena mentioned as well, built directly into the Snap. And we also have multiple versions available in the Snap Store. The latest is version 2025.2.0. And one tiny little caveat about the versioning that can be a little confusing is that OpenVINO itself uses date-based versioning just like Ubuntu. So the 2404 in the name of the Snap refers to the base OS. It refers to Noble. whereas the version of the snap itself is referring to the version of the OpenVINO runtime. So now, for pretty much the remainder of the talk, we're going to go on a journey together of building basically a hello world snap using the OpenVINO Python API. And so I'm going to start with a very basic Python script. And all this is doing is querying the supported devices that OpenVINO can see. I mentioned this can be one of the big obstacles you need to overcome if you're using more traditional packaging formats. You need to worry about things like driver compatibility with your application. The goal with the snap is to reduce that burden. And so this is basically a kind of a smoke test of sorts that shows you, okay, does OpenVINO actually see a GPU? Does it see an NPU? And can it run inference on those devices? And so the next step is to create our snap recipe, which is our snapcraft.yaml file. And it looks like this. So at the very top of your snapcraft.yaml, you have a bunch of metadata that include things like the name of your snap, your base OS that you're based on, in this case, Core 24, things like a description and a summary, a version. The confinement refers to whether it can access resources in the host or not. So in this case, we're using a strictly confined snap. And that means that in any cases where we need to reach outside of the snap and access resources in the host, we need to do that through an interface. And interfaces can come in the form of a slot side and a plug side. And so in this case, we have a plug that is going to plug into a slot provided by that OpenVINO Toolkit 24.04 snap. So that's the producer, and this consumer app that we're creating is the content consumer snap. And so the target in this case is going to use this $snap shell variable, which you can think of just as like the base root directory of the snap. And we're going to mount those libraries from the OpenVINO Toolkit 24.04 snap at a subdirectory called OpenVINO. And moving on, we're then going to define the parts within our snap. And this is basically the data, the code, or the libraries that you want to build into your snap and run. And so in our case, we have two different parts. The first is just that Python script that I introduced on the first slide. And the second one is called a command chain. And you can think of a command chain as a sort of wrapper script that gets run immediately before your snapped application that does things like sets environment variables and makes sure that the runtime environment is in a state that the application can function with. And then the final section will be our apps section. This is what we'll actually run. So we have just a single app that we're defining here called get devices. It's going to run that command chain script. I'll actually show you the script on the next slide. And then the command is our Python script, and at this point we have just one plug defined, and that's OpenVINO libs, which again, to remind you, is consuming libraries from that OpenVINO Toolkit snap. So as promised, here is our command chain wrapper. It's called source content producer. So as the name suggests, we are going to source something from the content producer. It's going to be just a couple of commands. And in this case, it's a very powerful way of, rather than building that OpenVINO launch command directly into the snap, we structure it this way so that when that snap gets updated, we automatically pull in those changes for free without having to rebuild this snap. And then the second line is just a requirement for any command chain script to ensure that it functions properly with the snap. All right, so now we're ready to actually test our snap. So we are going to go through the process of building it, installing it, and running it. And so the first step is to run snapcraft pack. And I had, like, full disclosure, I had run this once before, and so it runs quite a bit faster in this case. In the real world, it would take a bit longer. All right, so the artifact is this .snap file. And in the next command, we'll install it using sudo snap install -- dangerous, which sounds very scary, but it's just a conventional thing you need to do when you are installing snaps locally rather than from the store. Once it's installed, we can then run our application using the name of the snap, followed by a dot and the name of our application, which is get devices. So, okay, great. We've got a CPU that we see. That's the expected result. Ultimately, we want to have access to the GPU and the NPU as well. And so let's build in the GPU support next. So to do this, we're going to add a new part to our snap. This is the Intel graphics part, which is basically just taking packages that already exist in the Ubuntu archive for supporting Intel graphics on Ubuntu. So this is things like a graphics compiler, OpenCL libraries for Intel support, something called Level 0, which is very similar. And it's going to install all of that in a part so that OpenVINO can access them. The next part is a use at your own risk part. This is pointing to a PPA that is maintained by Intel and Canonical as a sort of staging area for those same graphics packages that ultimately we hope to land in the archive. So if you want support for the latest and greatest Intel graphics, then you might add this part to your snap graph, but it's completely optional. The next part is a layout, which is just a way of resolving sort of path-related issues within snaps and ensuring that the libraries can do things like find data that they might need when they're using hard-coded path. So it's a way of mapping one path to a path that's inside the snap where that data actually resides. The next bit we added was a new plug. This is the OpenGL plug, which is a very generic graphical support plug for Snapd. And so if you need any sort of graphic support, whether it's Intel, NVIDIA, AMD, this OpenGL interface is designed to be sort of a catch-all for any of those cases. And then finally, we are going to define an environment variable called OCL ICD vendors. Similar to the layout, this is like just an issue related to the path where OpenCL expects to find certain files and certain data. All right, so next we are going to rinse and repeat. I will not show the pack step this time. So just imagine that I have already built this snap. I am now snap installing it. And I will next run it. And as you'll see, we have OpenVINO now sees, wait for it, a CPU and a GPU. All right, so we're one step closer. The next step is getting Intel NPU support added in. So for that, there is another content producer snap, and this one is called Intel NPU driver. And so this is a content producer snap that packages a couple of things. The first thing is a user mode driver and compiler. And the second bit is the actual firmware, so like the binary firmware blobs for the NPU device, which might seem a bit odd that it's in this snap. But it's actually in the upstream repo from Intel, and there's a good reason for that, and that's because the firmware and the user mode driver have very tight coupling. And so to ensure compatibility, it's very important that those two components be installed together. And so within this snap, when it's installed, there's some automation that will automatically go out and it will reload a kernel module called Intel_VPU. VPU, I think, was the previous generation of the NPU, so there was a change in naming. But it's the kernel mode driver responsible for controlling the Intel NPU. And we have some automation in place. When this is installed, the kernel module will automatically be reloaded, and when it comes back up, it loads the new firmware. And so this ensures that the user mode driver and the firmware versions match. All right, and adding support to our snap is pretty straightforward. So we're adding a new plug. This one will look extremely similar to the last one we added for the OpenVINO interface. We're going to call it NPU libs. Again, we're using the content interface. And then we need to add that, we're going to add this new plug called Excel for NPU support. And that's a new snap interface that gives us access to the actual device nodes. So the kernel driver creates some nodes under /dev/excel. So there will be one device node per NPU in that directory, and that Excel interface is what gives us access for that. And then finally, we are going to update our LD library path so that it can find the NPU libraries. The application sees those libraries from within the snap. And hopefully, that will all work. So let's try this one last time. So again, you'll need to imagine that we've already built the snap, and now we install it, and when we run our Get Devices application, awesome. So we got CPU, GPU, and NPU support for our application. And just to summarize, we talked about some different snap interfaces that are pretty essential to get OpenVINO-powered applications to work. The content interface, OpenGL, and Excel. There's a couple of very important content producer snaps that we have already created and are available for you to consume. The first being OpenVINO Toolkit 2404, the second being the Intel NPU driver. And then there's some miscellaneous details around things like environment setup, command chains, layouts that I also discussed. One other very important detail that I haven't mentioned yet is that the user that you're running as will need to be in this special Unix group called the render Unix group. And that's because the device nodes for the accelerators are owned by that group. Okay, and there was a QR code. I was very liberal with my QR codes in this presentation. They're sprinkled throughout. On that previous slide, if you want to get access to that sample consumer Snapcraft code, you can follow that QR code. Okay, so that was basically a hello world. And from there, you're really equipped to design your own OpenVINO-powered apps, but there's already some that exist out in the wild. Namely, there are plugins that have already been developed by Intel for 3 very popular Linux desktop applications. GIMP, which is for image editing, Audacity, which is for audio editing, and OBS, which is for video recording and live streaming. And in addition to that, there's also these Inference snaps that Farshid and his team introduced yesterday that also make use of a lot of these same building blocks that I've introduced in this talk for integrating with OpenVINO, the NPU, and the GPU from Intel. All right, so let's see some demos. We'll start with GIMP. The first feature that will be demoed is stable diffusion or image creation. And so my prompt here was a cartoon of a polar bear on a surfboard. And it results in a very nice image. The second plugin we're going to run is super resolution. And so this will allow us to blow that image up by a factor of 2. It'll be run on the NPU. And the final plugin is something called semantic segmentation, which will essentially just select the unique or distinct areas of an image for you. And this will be run on the GPU. And so this has already been packaged up in its own content producer snap. It's called OpenVINO AI Plugins GIMP. And if you scan that QR code, you can find a lot more information about installing that from the store. And it's already very tightly integrated with the GIMP snap as a content producer snap. Okay, the second, this is my demo slide of Audacity. Okay, great. There will be some audio, but it'll take a minute. So Audacity is for audio editing, and the plugins from OpenVINO provide features for music generation, noise separation, super resolution, music separation, and transcription. And so here I'm demonstrating this on my laptop, which in my case just contains a GPU and doesn't have an NPU. And I'm going to run this music generation plugin, which takes about a minute or so to generate 30 seconds worth of music. Let's see if we get the audio. Okay, nice. It's a risky prompt this time of day and at this point in the presentation because everyone wants to fall asleep already. But it's very versatile. You can use lots of different prompts. You do need to be quite specific and do a little bit of prompt engineering, I would say, when you're toying around with this. But it's a nice way if you're into audio to have some fun. These plugins, again, like the situation with GIMP, have already been packaged, and in this case, they're actually built directly into the Audacity snap. So when you install Audacity from the store, you'll get those plugins for free. And then finally, for OBS, we've also been working on some plugins. These aren't quite released at the moment. They're under review, but they provide features for background concealment, face mesh, and smart framing. And I'm demoing 2 of those features in the video on the right. But we hope to land those in their own dedicated content snap sometime in the next weeks. And then finally, the inference snaps, which we've already seen from Helena and we saw yesterday in the demonstration, so I won't spend much time here. But again, these are leveraging a lot of the same components and packaging techniques that were used for GIMP, Audacity, and OBS. And they're optimized for Intel CPU, GPU, and NPU. All right, and that's it, and we're happy to take any questions.